Okay, let's face it. Georgina Ranger Huffman asks, how many micrograms of vitamin B12 should be consumed daily on a whole food plant-based diet in the form of methylcobalamin, 1,000 micrograms, or cyanocobalamin, 1,000 micrograms? The recommendations are anywhere from 2 micrograms to 7 micrograms a day, depending on which studies you read. But we need to take more than that because of different abilities to absorb. So, anywhere from 50 to 100, you can take as much as 1,000 micrograms, depending on your ability to absorb. You can follow B12 levels to find out what's really being absorbed and how much you really need. But the body only needs anywhere from 2 to 7 micrograms per day. What does B12 do in the body? Well, it's involved in the central nervous system, in the peripheral nervous system, in its growth and development, and as well as blood. It is part of what's necessary to make blood, red blood cells, etc. It's involved in DNA synthesis. It's involved in the production of methionine from homocysteine. So it has many, many different actions in the body. It's really, really important. Every cell uses it. So what is it? What is B12? It's a very complex water-soluble molecule, and it's produced only by bacteria and archaea. Archaea are small single-celled organisms, once thought to be bacteria, but only bacteria and archaea can produce it. So even when we think we're getting our B12 from an animal, we're getting our B12 from the microorganisms that live in the animal, or that the animal has consumed. How is B12, when consumed, taken into the body? It's a little bit complex. There are cells in the stomach called parietal cells which produce hydrochloric acid, because we should always keep in mind that our stomachs require a very low pH, okay, not a high pH, not alkaline, but very acidic. So parietal cells are there. They produce that, and they also produce a protein called intrinsic factor. And intrinsic factor binds to any B12 that's taken in by the body through eating, and or any other way, as long as it gets through the mouth. And it's then able to be absorbed in the last part of the small intestines called the ileum. That's sort of the normal process of it. Now, what we find is that Indians who do not immigrate anywhere, and this study was done in England. They found they looked at Indians who migrated to the UK from India versus those who grew up there, and they found out that the ones that migrated or immigrated there had a much more bacteria in their small intestines than the ones who grew up there. So apparently Indians are getting more bacteria somehow, and they're surviving in their small intestines than normal. And they also did not have the B12 requirements that the people that grew up there do. Now, this is also found in apes. Apes living in the wild do not need B12. But once we bring them into captivity and we feed them the vegetables that we eat, they do. And what's the difference? Well, we sanitize ours, we clean ours, we make sure that there's not anything at all left on it, which again is unnatural. What we do know is that there are many organisms in the colon that produce B12. But if it's produced in the colon, the problem is that's past the ileum, and so it will not be absorbed. So they find that some animals actually eat their feces. By eating their feces, their B12 requirements are met. There was an experiment done in the 50s, again in England, where they took the feces of vegans and extracted the B12 from it and gave it to them, and they did not require a supplement. They were fine. So clearly, this was proof that we do have the bacteria in our colons to produce B12. Now, it has also been found in later studies, as far up in the 80s, that when there is a small amount of protein in the diet rather than a large amount of protein in the diet, these bacteria are able to migrate up to the small intestines. And then when they do, of course, they can be combined with intrinsic factor and then absorbed into the distal ileum, the last part of the small intestines. And so what is the conclusion here? The conclusion is that our modern lifestyle which is allergic, as you were, to nature, cleans and makes sure that everything is sanitized. And when we do that, we remove the bacteria that we would normally ingest and who would take up residence probably in our small intestines. We also, because of our unnatural eating of high-protein diets, do not allow the bacteria that are in the colon to migrate upwards and produce their products there for us. So we come around again to the same theme. The same theme is that we are primates, we are divine primates, and that we are capable of living in nature the way nature designed us without taking any supplements. The word supplement means that we need an addition to our diet. But nature did not make us defective, that we would need something man-made in order to survive. That's very, very illogical thinking. So supplementation is only necessary when you're living against nature or in adversarial to nature the way we do. So living a natural life, pulling a carrot from the ground, shaking it off, of course, you're going to get the dirt off and eat it like that, is how it should be. That's natural. That's fantastic. That's how we should be. All of nature does this. We are the only ones who think that we must avoid nature. But keep in mind also that the vegan supplementation is now made with bacteria. So that is what a vegan supplement is when taken in some sort of, either in food that's fortified. You want to make sure that it was produced by bacteria specifically for that use.